So after talking about parallel lines, it is only natural that we will now begin a discussion of perpendicular lines. So perpendicular lines, I've got myself a graph going here. I've got a line going this way, then my perpendicular line would come across like that. Now these lines are considered perpendicular because they meet at a right angle. This should be really familiar to you. This is just more like a review. It's like a t-square or a 90-degree angle, however you might consider it. All right. Now the idea behind perpendicular lines is that two lines are perpendicular, and the sign for perpendicular is that, the t-square. Two lines are perpendicular if, and this is where it sounds really funny, if the product of their slopes is -1. Alright, so if that doesn't sound funky, I don't know what does. Probably the way you maybe one of the ways you've heard it is if their slopes are, you heard the phrase opposite reciprocals. That might jog your memory. Alternatively, you might say if you can take one slope, flip it, and change the sign, and you get the other slope. Now, if that's true, then you've also got perpendicular lines. All right, so let's talk about what perpendicular lines look like. So if I have slope of line 1 and I have a slope of line 2, and we're going to say that this slope is perpendicular to the first one. So if my first slope is, say this first slope here is 3. To get my perpendicular slope, it means the product of this and 3 need to be -1. Another way to think of it is opposite reciprocal. If you've done opposite reciprocal, the opposite has to do with the sign. Reciprocal means to flip it. So I'm going to take my 3, which I'll remember is 3 over 1, and I'm going to flip it to get 1/3, and then I'm going to stick a negative sign out front. So the slope of my perpendicular line of slope is 3 is slope equals -1/3. All right, so if I have a slope of 1/2, to get the other slope, I'm going to flip it. So I'll get 2 over 1, and I'm going to stick a negative sign out front. Stick a negative sign out front. So you might call that -2. Okay? Getting it? Flip it, change the sign. So if I've got one that's, let's try, so I've got -2/3. If I want to get the slope of a perpendicular line, I'm going to flip the 2/3. So I've got negative. Well, you might not even write negative if you don't want to, because what I'm about to do, I'm about to make it positive. So I'm going to flip it, and I'm going to make it positive. So the slope perpendicular to -2/3 is 3/2. We'll just do one more and make sure you got it. So if I've got 5/2, like that. If I have 5/2, I'll flip it and get myself 2/5. And I'm going to stick a negative out front, and that's all there really is to it. Okay, just find a perpendicular slope. Got it? So let's look at a group of problems where we say, okay, are these two lines perpendicular? Okay, let's take a look. Are these two lines perpendicular? Say we've got 3x minus y plus 1 equals 0, and x plus 3y minus 18 equals 0. So we say, what are we going to do? And you're going to say, what? Find the slope. Oops, it's supposed to be blue. I'm going to say find the slope. Alright, so we've got line 1 is 3x minus y plus 1 equals 0. So to find the slope, I get the y by itself. Get 3x minus or plus 1 is y. So if y equals 3x plus 1, the slope is what? What's the slope? Slope is our m. Alright, so let's look at line 2. We had x plus 3y minus 18 equals 0. Alright, go ahead and move the 3 over. Got x minus 18 is negative 3y. I'm going to go ahead and switch directions. Just get my y on the left. Divide both sides by negative 3. If I'm going too fast for you, just pause it. Pause it and go work it out. It's not a big deal. That's what the pause button is for. And remember, we want to break this out into 2 different options. So that's going to be negative 1/3 x plus 6. And our slope over on this side is going to be negative 1/3. So now the question begs, are these lines perpendicular? So if I have a slope of 3 and a slope of negative 1/3, are they perpendicular? And the answer is yes, they are. So like we said, you can either multiply them together and get a negative 1. That's one way to prove it. Or you can say they're opposite reciprocals of each other, or however you want to put it, but yes, they're definitely perpendicular. So what I'd like to do right quick is go and graph these on your calculator. So here's a note about calculators, because I know we love calculators and all that stuff, but we've got these 2 equations, and we just proved that they're perpendicular. But if we go graph them, we might not be as convinced, and we might be tempted to change our answer. So we've got 3x plus 1, 3x plus 1, and we've got negative 1/3 x. Ooh, that's not what I meant. I'll just do it this way. Negative, I'll just do it as x over 3. Negative x over 3, just like we had up here. Just like we had up here. Ah, made a mess. And then plus 6. And I'm going to graph it. So we just proved that these are perpendicular. But you might look at these lines now in your viewing window and say, hey, these lines are kind of cattywampus. This one's going off this way, and this one's going off, kind of, that's not a perfect right angle, so I must be wrong. You might be tempted to put no. But here's the deal. If you'll notice the distance between these tick marks here on the x-axis, and then compare them to the distance between the tick marks on the y-axis, you can see that they're different. They're not the same spacing. And the reason for that is that you don't have a square window. So what you want to do is you want to go hit your window button. Not your window button, sorry. You want to hit your zoom button. And here where it says number 5, where it says z square, you want to go down to square. I went too far. And hit OK. Now when I do that, over here I have the benefit, because I actually have this little graph here. You can see just briefly the difference. You can see them both on the screen at the same time. You can see the difference. So again, right before you hit 5, remember how cattywampus this is, and then hit enter. I can never get off my thingy. Go, enter. Try it again. Oh, what did I do? Oops. I learned how to do something new today. Okay, where did it go? Come on. Alright, now I'm going to hit enter. And it graphed. Isn't that pretty neat? So now this looks a lot more, if I could do that again if I tried, probably not. I wonder how I did that. That was kind of neat. That's not how. Anyway, as you can see here, if you look at this, this is a perfect X, a perfect square, if you want to think about it that way. And, oh, I did it again. I'm amazing. Let me go get them. So there I did it. I dragged it. So you can see this is a rectangular plot. This is the default. This is the default. And this is the square. So looking at these side by side, you can see that this is a smaller angle and this is a bigger angle. So you might not think that these are in fact perpendicular, but they are. If you square it off, you'll have a perfect angle where they're both square angles. Okay, so just beware when you're using a calculator that you don't see something goofy. All right, let's do one more problem in this section. Well, not just one more problem in this whole section, but at least one more problem to kind of get you going. So, are these lines perpendicular? So if I gave you 2x minus y plus 3 is 0, and x minus 2y minus 2 is 0. So what are we going to do? We say, I'm going to find the slope. Alright, so I've got line 1 is 2x minus y plus 3 is 0. And I'm going to go kind of fast because I assume that you're getting good at this algebra thing. Maybe falsely assuming, but I'm assuming nonetheless. So y equals 2x plus 3. And my slope is 2. So let me go and look at line 2. Also, x minus 2y minus 2 is 0. I'll move my 2y over and get x minus 2 equals 2y. 2y equals x minus 2. And I'm going to divide both sides by 2 and get y equals x over 2 minus 1. Really meant to write 1/2 x minus 1. So my slope over here is 1/2. So, are these lines perpendicular? And the answer is no. If you multiply them together, 2 times 1/2, you get a positive one. Remember, we want a negative. They're not opposite reciprocals. So basically the problem with this here is you're missing a negative sign. So these lines are not perpendicular.